Okay, so these are going to be the solutions for projectiles 1. What's the definition of a projectile? That's an object moving under just the influence of gravity. And an example of a projectile would be a ball thrown into the air. Following that nice projectile path. For a non-example, an airplane is not a projectile. It's got lift going on. It's not just gravity. It's not in free fall with a forward horizontal velocity or rocket. Neither of those things are projectiles. What is the vertical acceleration of a projectile? The vertical direction is the y direction. The vertical acceleration of a projectile is gravity, or 10 meters per second squared, down. This pulls the object down in the y direction. That's what's going on in the y direction. The horizontal acceleration of a projectile, horizontally, that's the x direction. If we look at the horizontal acceleration, that acceleration is going to be 0. Horizontally, that object is moving with constant velocity. Also, if gravity is the only thing influencing us, gravity is only in the y direction, and there's nothing else in the x direction. So if I have an airplane flying straight and level dropping a bomb, the bomb lands, if we ignore air resistance, below the plane. Both objects have the same horizontal velocity. So the airplane is going to be flying and the bomb is going to stay just below it the entire time. We could say package instead of bomb. That's probably a lot better. But let's say this is our airplane. And our airplane is going to be moving, we'll just track the tip of the airplane. Here, 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 here. That's a constant velocity. Every second, that's where the airplane is going to be. And when we drop the package, well, it's still going to be moving horizontally with the same speed, but vertically, it's going to be falling farther and farther each second. So even though it's falling, it's going to stay right below the airplane the entire time because that horizontal velocity doesn't change. It's going to stay the same the whole time because there's no acceleration in the horizontal direction. The picture shows a projectile launched at an angle. So let's do the horizontal velocity vector and the vertical velocity vector. Well, I know horizontally, if we're looking at it, we'll do that in blue. There's no acceleration, so the x velocity is going to stay the same the entire time. But in the vertical direction, just like an object that we throw up and down, if we look at the vertical velocity vector, we start off with the velocity in the y direction, but that's going to slow down, and it's going to stop at the very top. The velocity in the y direction is 0 at the very top, and then it's going to turn around and speed up. That's what's going to happen with the vertical velocity. Sketch the position versus time graphs and the velocity versus time graphs for the horizontal motion and the vertical motion of a projectile. Let's just do it for the one that we just did. So we'll look at the x direction stuff here. So x as a function of time, and then the velocity in the x direction as a function of time. Well, we said, and we looked at having a constant x velocity the entire time, so that's not going to change. And so my x position is just going to increase linearly because in the horizontal direction, the velocity is constant. But if we go to the vertical direction and we look at what's happening in the y direction, and we look at the velocity in the y direction as a function of time. So here we start off with positive velocity in the y direction. We get to 0 velocity in the y direction, and then we get to negative velocity in the y direction. So if we look at y velocity as a function of time, we have this nice line with negative slope the entire time. And if we look at the y position, we're going to go straight up and come straight back down in the y direction. So y position as a function of time is going to look like this, where this is the very top where we have 0 velocity. We move up here, we're moving up here, moving down here, and we're moving down there. In the vertical direction, our object has a constant negative acceleration. At all points, we have a constant negative acceleration.